So there's a question here. 2 to the x equals 2 to the 3. Now the first thing that we want to make a note of is x in the exponent so this is an exponential equation. So that's what we're doing today. And this is going to let us solve some slightly different applications. The applications we're going to start tomorrow and we'll do the next day as well are going to be worded very much the same as the ones we did yesterday, but they're going to be asking a bit of a different question. Okay, and so we'll see that tomorrow. We'll leave that to tomorrow. But so it's giving us a new skill. So all of the equations we're looking at today, they'll all have x in the exponent, exponential equation. Can anybody tell me anything about this? Jada. You got to make both sides equal. So what would make both sides equal? If x equals 3. So this is exactly how we solve these. I just draw a conclusion. Therefore, x equals 3. This must be true given how this is set up. Okay, this must be true. And I'm going to write that down again, like I'm going to make another note over here. If the base of each power is the same or are equal, the exponents must be equal. So this is our strategy, our technique, our procedure for solving these, is to make sure that the base, which in this case is 2, the base is 2. 2 to the x and 2 to the 3. So 2 is the base. If the bases are the same, the exponents must be the same. Seems easy enough? So and that's the most important part of understanding how to do this. So you got to remember that that's the first thing you have to do, is make sure that you have the base the same on both sides. We okay with that? That means if I have 2 to the x equals 3 to the 2, I can't solve this. And in fact, in this course, we would never learn how to solve this. It requires a totally different kind of math. Okay? Or if I had something like this, 2 to the x plus 5 equals 2 to the 7. That 5 is in my way. So we couldn't solve something like this. Now we're not going to see, I'm not going to give you a question like that, although when we start applications, it'll sort of have another element to it. But like this is not ready to be solved because I don't just have, like over here, all I have is a 2 to an exponent and a 2 to an exponent. I don't have any other junk. So this one, again, is not solvable with this system. Only some kinds of exponential application or exponential equations can be solved like this. Only some. But all the ones that I give you will work. Okay. All right, so let's try some examples. Now you see right away it's not quite as easy as a one-step solution like the last question where you just say therefore x. There's going to be some extra steps to some of these. But when I look at this, I've got 5 to the something equals 5 to the something. Therefore, those two somethings must equal each other, whatever they are. So in this case, and we always write a therefore symbol when we do just this step, and some people don't understand why, and they put the therefore in the wrong place. Like they always put therefore in this, where when they get their last answer, that's not where it belongs. There is a reason, we won't dwell on it too much, but there is a reason, so I would encourage you to get in the habit of doing this, okay? There is a reason why we write it, the therefore symbol. It's because we're not doing an operation to go from this step to the next step. And the next step is this. We're drawing a conclusion with just deductive logic. We're just noticing that, hey, the bases are the same. In order to balance the left side and the right side, the exponents have to be the same. Like they have to. There's no other way to do it. And because there's no operation, the standard in mathematics is we put a therefore symbol kind of thing. Okay? So now, but I'm not done yet, right? We're supposed to find x, but this is supposed to be easy. This is like a grade 9 question. What do I do? Yeah, just divide both sides by 3, and I get x equals -2. And some people like to show that, so go ahead if you like to. You don't have to. All right, next one, 3 to the x minus 3. So now I've got like a binomial in the exponent, but it doesn't matter what's in the exponent. It's 3 to the something equals 3 to the something. So therefore, x minus 3 has to equal -7. The fact that the exponent's negative, the fact that it's a binomial, none of that matters. You're looking at the base. If this was 3, let me do this in a different color. If this was 3 to the x minus 3 equals -3 to the 7, you couldn't do it. So, or to the -7 or whatever, you couldn't do it because that's not the same base. They don't have the exact same thing on both sides. Okay? The base has to be exactly the same. And that brings us to question C. Where the base is a fraction, but it's the same fraction. It's in brackets to show that the exponent's on the entire fraction. And so, again, it's the same thing. I can go straight to this next step. Therefore, x over 4. Oh, we didn't solve that last one. Whoops, sorry. How come you didn't remind me? How do I solve this one? I add 3 to both sides. So I get x equals -4. And you can always do a quick check on your calculator. We'll look at that with a better question, or in your head. If I put a -4 in here, I get -4 minus 3, which is -7. So 3 to the -7 equals 3 to the -7. Like it works, right? It makes sense. So you can always do a check with these. Okay, so x over 4 equals 5. How do I solve this one? Multiply both sides by 4. Any questions about that before we move on? That's the pivotal, important understanding of how these are solved. Now, there's still going to be some different kinds of questions. There's a few new ones, like they're a little bit different. Some other stuff that we need to understand as well. But that's, to me, maybe the most important step, that you understand base is the same on both sides. All right. Let's try D. What's different about D? Yeah. Now, you might be able to solve this by inspection. You might know what x should be. And this is a simple one, so if you could do that, then fine. Like, that's good. But we're going to solve it the way that we're going to solve all of these, because some of them you're not going to be able to just figure out. In fact, we'll do it right here. So what this is asking is, what exponent would I put on a 2 to give me 16? So I'm going to use my calculator, and I'm going to start figuring that out. Like, that's what an equation is asking, right? When there's an x, it's asking, what would I put into the x to make this true? What exponent would I put on a 2 to turn it into a 16? So I start trying things. We already saw 2 to the 3 before. Oh, we didn't evaluate it, though. So I could try 2 to the 2. Now, I know that's not going to work because I know some of these. And some of these you will know, but not all of them. So you're going to have to do some guessing and checking on your calculator. 2 to the 3 is 8. 2 to the 4, got it. But I don't just then say x is 4. I say 2 to the x. I rewrite 16 as a power of 2. And then I go, therefore, x equals 4. And this is a must. You must write them properly and solve them the correct way. And again, this is because when they get hard, like for this one, I know it seems what's the point, why bother? But you'll see for the harder ones why it's necessary. This is what people will want to write, but this is wrong. So you'll have your question, which is 2 to the x equals 16, and you will want to write 2 to the 4 equals 16, therefore x equals 4. But this is wrong, bad form. Notice the difference and try to get used to the correct way of writing it. We still write, because this one is all of a sudden missing an x. And that's not how we communicate in mathematics. Okay, so we got to have consistency, so you should have an x on every line. So you get used to this step and writing it correctly. That's another thing that you kind of want to be thinking about today. And as long as you can do that, and you can use your calculator to do some guessing and checking, should be pretty good. Let's try another one. So right away, this one's a little bit trickier. So this is 10,000. It's got 4 zeros. So you might know what power you would put on a 10 to do that. And even if you don't, you'll notice the pattern quickly. 10 squared is 100, so I'm not going to do that one. What about 10 to the 3, 10 cubed? That's only 3 zeros. What about 10 to the 4? That gives me 4 zeros. So you might already notice that powers of 10, the exponent is how many zeros you're going to have. So if I just count 4 zeros, I know it's going to be 10 to the 4. So I write it like this: 10 to the negative 2x equals 10 to the 4. And then therefore, negative 2x equals 4. The exponents are equal because the bases are equal. And then divide both sides by negative 2, and I got it. And watch my check. 10 to the exponent. So I want you to have your calculator ready because you're going to do some of this guessing and checking as well. 10 to the negative 2 times, now my answer, which is also negative 2, and I'm going to hit, and because I have a good calculator, which most of you do, I can type it in exactly like that, hit equals, and I notice that I get 10,000, 10 with 4 zeros, just like the question, so we're good. Sound good? All right, let's keep at it. That means negative x over 3, by the way. If that's not clear, it's like negative x over 3, a fraction. For these ones, putting a fraction in an exponent makes everything get really kind of small and harder to read, so that's why I often do it with a side slash. And I even kind of write it that way so you can too if you want. So here's another one. What's my first step going to be? What do I have to do?
Write the bases as the same.
So what am I going to write? What am I going to do?
You're going to write 2 to the exponent, negative x divided by 3 equals 2.
2 to the something, and we got to figure that out. Very good. In other words, we're turning 64 into a power of 2. So 2 to the negative x over 3. So see how I kind of do it like slanted leaning there, equals 2 to the something. And I'm going to go to my calculator, and I'm going to start trying different things until I get there. What do you think I should start with? What would you guess? 6? So you said that because you know that's the right answer? But like, it's what do you think? Could start with 3. We did 3 a couple of questions ago. Maybe you already remember. Like, I don't know. This is the thing, right? So it depends on where you start at. So this is kind of forced because we already know the answer. But if I do 2 to the 3, and the more you practice, the more you'll get a sense of how big you should go. What if you're like, oh, 64 is pretty big. Maybe I'll start at 2 to the 10. Whoa, way off. So, and that's fine. Okay. Won't take you that long. So then I go, wow, what about 2 to the 5? 32. Okay, so it's going to be one more because it's just double that. So 2 to the 6, sure enough, is 64. And then I say, therefore, negative x over 3 equals 6. Multiply both sides by 3. Negative x equals 18. And x equals negative 18. The negative sign just flips over to the other side. So if you want, you can do it for any of these questions, but if you want to make a little note to yourself on what you do, okay, we have to turn 16 into a power of. The first 3 examples we did, they were already expressed in the same base. If they're not, that's the first thing that you have to do. Turn 16 into a power of 2, and then you can say the exponents are equal. Zero 0.5 to the 2x over 3. So this is how I'm going to do this one. Sometimes we start to confuse ourselves. So I'm going to go 0.5 to the 2x over 3 equals 0.5. And whether you want to do a box or not, I don't know. But this is what we have to do. So I have to figure out 0.5 to the something equals 0.25. On my calculator, I need to be punching exponents in on 0.5 and get 0.25 out. So 0.5 to the 5. Nope, it's a disaster. 0.5 to the 4. 0.5 to the 3. 0.5 to the 2. Gives me 0.25. That's what I'm looking for. So 2 is what I want in that exponent. You can go ahead and finish that one. So I got x equals 3. Is that what you got? And I'm going to do a check again, 0.5. Now, if you have a different calculator, you might have to put brackets around your exponent or something like that. I wonder if I have an example of one here. No, I don't. So you might have to, again, a little bit of practice working with your calculator to get good at this and figure out how your calculator does this stuff. But with this calculator, it shows you the exponent, so it makes it pretty easy. So I'm going to do 0.5 to the 2 times 3 divided by 3, because that's what this exponent is. So 2 times 3, because I got 3 for x, right? That's why I'm doing this. Divided by 3 equals 0.25. That was what we were looking for. So that's an informal left side, right side check. We've done left side, right side checks, and you could do it formally as well if you were asked to, but this is an informal one. All right, I think this is our last example. And this one's just a little bit trickier because I don't know the powers of 0.5 at all. So I have no idea what that would be. But I do know, so I'm going to write this. It's got to be 0.5 to the x over 4 equals 0.5 to the something. I do know that. Okay, somebody, wild guess. Hopefully you haven't started trying things yet. A couple of you have. Wild guess, what would you start with? Sir? 5, I like it. So I'm just going to, you wouldn't have to do this. You can do all of this on your calculator, but show my work here just for the lesson. 0.5 to the 5 gave me 0.03125. Didn't work. 0.5 to the 6. It's kind of close though, right? Like, so 6 might be good enough. If I wasn't even close, I might skip a few and try a bigger one. Still no, it gave me 0.015625. These numbers are getting smaller, right? When you do an exponent on a decimal, on a number smaller than 1, I should say, you get smaller. So let's try 0.5 to the 7. And that looks like it. 0.00782125. So to the 7. Multiply both sides by 4, and x equals 28. And again, I can do a quick check to the x is 28, so 28 divided by 4 gives me the right side. Very nice. I don't think there's any today. I don't think so, but there will be a rare occasion where you won't get an exact answer. And what we'll actually have to do is try a few, and we'll try them, and we'll actually write them out like this and just pick the one that's closest. Okay? And this only works, like what about 0.5 to the exponent 5.5? Like you can put decimals in there. In fact, we've talked about fractions and decimals and exponents a little bit in this course. You get a different answer. But so like you could, estimate it even more accurately, but we won't have to do much of that. We'll do a little bit of estimating, I think, starting tomorrow. But usually you can get the exact answer, and we'll usually just be looking at whole numbers.